And so you should know that. So I'm letting you know. So the recording will start here in just a few seconds, but let's see. All right. So we can go ahead and start the meeting. Um, so let me see. I thought I would start with just getting everybody acquainted with how our class is going to work. All right. So I'm going to share my screen and I want to show you some stuff that's on Canvas. Okay. So if you can, could somebody let me know in the chat or somehow if you can see my screen? You should see Canvas because that's where the stuff is that I need to show you when I start. Okay, good. All right. Um, so anyway, so you're seeing Canvas right now, and I wanted to walk you through some things that are there. And I won't go over all the stuff that you see here. Some of it I would like you to read on your own, but this will get you started, okay? And as I go through this, at least for now, hold on, I gotta let somebody in. All right, so at least for now, if you have something to say, just go ahead and turn your microphone on. I'll be able to hear you and you can ask the question. All right. So anyway, first thing is we're going to use something called My Math Lab. And I sent an announcement out, I don't know, a few days ago. And right now you're looking at it. Okay. It gives you the web address for My Math Lab. It gives you all the enrollment information, etc. Okay, all of our assignments this semester are going to be done on My Math Lab. So I sent this out a few days ago so everybody could get enrolled in it. I wanted everybody to be able to start right away. Okay, so that's under announcements. You can find any announcement I post or send to you here under announcements. You'll get a copy of it in your My TCCD email also, but if you wanted to look back at them, they're all right here. Okay. So the next thing I want to tell you about is modules. So let's look under modules. Most of the stuff that I post is going to be here under modules. Okay. So first thing, let's look at this thing called the course information document. All right. What this is, in my opinion, is like the syllabus, but it's a lot easier to read. Okay. I put it together in the form of like a frequently asked questions type thing. Okay. So first, a little bit about me. So my name is Jeff. I'll be teaching the class. Um, I'm perfectly fine if you call me by my first name, Jeff. That's, in fact, I would prefer it if you call me by my first name, Jeff. But I've been doing this long enough, I think. And anytime that you ask me something or ask for help, then I get to do the thing about this job that I like the most, which is to teach math. All right. But anyway, so that's a little bit about me. Um, as far as how to get a hold of me, I would prefer that you contact me by that email address right here. Everybody has a my.tccd email, okay? Now, I say this because there are lots of other ways that you can get a hold of me. I have, like, Canvas has its own messaging system, and I also have an Outlook email, and it's just easier for me if everything gets sent to the same place. All right. So if you contact me some other way, you'll probably get an automatic reply from me that says to contact me here. I just like the Google Mail a lot better. It's much easier to use, so that's my preference. Okay. All right. Now, as some of this stuff won't make a whole lot of sense now because I think we're going to have to start working some of the assignments to really understand it. But we'll have three types of assignments. We're going to have tests, and we're going to have quizzes, and then we'll have homework assignments. and they all have different weights. And this is the formula that I'm going to use to calculate your final grade, right? So you could check your grade here in the grade book on Canvas. You see right there where it says grades? That's where you can see all your grades posted as we go throughout the semester. But there will be like a final grade in there too. And if you had any doubt about it, you could check, the math right here with this formula. All right. I dropped some of the assignments. I dropped the lowest quiz, and I dropped the 5 lowest homework assignments. All right. So for that reason, I don't do makeups on the homeworks. Hold on, somebody is in the lobby. Let's see what's going on. Okay, admitted. All right. What was I saying? Yeah, so because I dropped so many homeworks, I don't do makeups on those. You can still review them. I mean, if you missed it, you can review it after the due date. If you didn't complete it, you can still review it. I'll show you a little bit about that once we talk about MyMathLab. But all of these assignments are going to be in the same place on MyMathLab, and I'll show you a little bit more about that in a minute. Okay. Anyway, so let's go now. This course information document, I'm not going to read the whole thing to you because, I think it's one, I posted it, and two, it's probably too much information at one time, but I want you to read this later, okay? For now, I wanted to tell you about the assignments and about the grading, and I wanted to point out the fact that there's a calendar, all right? So there it is. Here's every graded assignment for the entire semester on this calendar. All right. So you can see all the homeworks. You can see we'll have like 4 homework assignments, and we'll have a quiz, and then we'll have a test. All right. And I mean for you to do things in this order. Okay. And the way I've got it set up is you learn everything on the homework, you practice it, then the quiz gets you ready for the test. And then once you feel like you've performed well enough on the quiz, you take the test. All right. All of these assignments, you get as many attempts as you want. Okay. You can repeat the problems until you get them right. The quiz, you can take it as many times as you want to. Because of all the repeated attempts and unlimited chances, you can get 100 on every assignment if you really put the work in. All right. But, once you get to the quiz, I think your performance on the test is predicted by how well you do on the quiz. So you could take that quiz as many times as you want until you get the grade that you're happy with. And that's probably about how you'll do on the test. All right, so that's how I got it set up. Assignments, quiz, test, assignments, quiz, test, all the way through the end. 4 tests. Once you take the 4th test, semester's over. All right. Okay, so but I'll show you what all this looks like on MyMathLab here in a little while. Let me see. Oh, about the assignments. When we have these meetings, I'll be going over some of the material for the assignments. Okay, some but not all. The scope of our meetings was never really intended to cover all the material in the class. Okay, so what we'll be doing is this. If you go back over here to modules, we were just looking at the course information. All right, but under the test 1 module, there's this videos for test 1. Okay, so I have made videos for everything in the class. They're all right here, ready to go. You could work at your own pace. Okay. Some of the stuff I'll go over during the meetings. Okay. But all of it is right here for every assignment. Okay. I say all of it. There's, 99%, virtually all of it. And if there was something in one of the assignments that you didn't see somewhere in the videos as you go through them in, this order, then you could ask me about it and I can help you out that way. All right. But virtually everything is right here. Some of it I'll go over in the meetings too, and of course during the meetings you could ask questions and I'll allow some time for you to practice some of the stuff that I've showed you, but it's all right here, okay? So I have classes, I teach the same class in another format where we don't have any meetings, and they learn everything through these videos, through asking me for help occasionally, and through features that are provided on MyMathLab, which is where the assignments are, okay? All right, so you've got this at your disposal. You can go through it at your own pace, however you want to. And of course, they're videos, so you can watch them as many times as you want or need to. You can pause them, you can take notes, you can, anything that works for you works for me, okay? All right, so let me see. Let me go back to modules. Now, this is the course information, and I told you I wasn't going to read the whole thing to you. I would like you to look at the rest of it, okay? I put it up here so you'd have access to it and so that you would be able to look back at it and so you'd be able to know what to expect. So go ahead and read that. Make it one of the first things you do. I've had it up here for a while. Some of you may have already read it. If you haven't, go ahead and do it, maybe tomorrow. All right. Let me think if there's anything else I want to talk about here. I don't think so. Let me see. No, I'd like you to look at the rest of it. All right. Now, let's do this. Let's look at this calendar. All right. I was just showing you the video list where the videos were sorted by assignment. Okay. Now let's look at where you find the assignments. So, okay, say you look back at this link, look back at the MyMathLab enrollment information, and if you go to that website and enroll as it says to do, then you'll end up over here. And once you create your account and enroll in the class, then you'll end up over here, okay? So what I'm looking at now is these are all the classes I'm responsible for right now, okay? And this is the class that you're in. So I'm going to click on that. And what I would like to do is show you that you can find every assignment on this calendar. All right. So now we're in MyMathLab. First of all, I would ignore the grade book that you see here in MyMathLab. Okay. The reason for that is the grade book here does not consider these weights, right? The weights are that tests are 75%, quizzes are 15%, the homeworks are 10, all right? So you'll see a grade book and it will average your grade, but it doesn't take this into account that tests are weighted more heavily than the other assignments. All right, but it's there, but I urge you to ignore it. If I go to assignments, I can find all of those assignments that were on the calendar. And so here they are up to the first test, okay? All right, so you can just, like I said, you can go through them at your own pace. Just keep the due dates in mind, and I would encourage you to not wait until the day something's due to start it, but I mean, ultimately that's your decision. But all right, here they all are. Now I don't have every single assignment, right? I just have it up through the first test, and once the first test is behind us, then I'll put the stuff up for the second test. I'll put the videos over here under a different module for test 2 and so on and so forth, but that's where they all are, all right? So anyway, how would we go about doing the assignments? Well, just click on the first assignment or click on whichever assignment that you want, all right? And you can start anywhere you want, but here's a summary. I've messed around with it already a little bit, but I can open a problem and so on, okay? All right, and I'll the problem is up here. We put our answer in down there. This part right here gives you a little bit of information about how you should format your answer, okay? One thing that can be frustrating about MyMathLab is MyMathLab is a computer program, and it can, if you don't, as computers do, things have to be just right sometimes for it to understand what you're doing, okay? Anyway, so yeah, like there's some kind of note here about how to put your answer in, then do it that way. Also, if MyMathLab is counting things wrong and you don't think they're wrong, then you can mention that to me anytime. All right. And it might be some simple formatting issue. And if you got it wrong unfairly, then tell me and I can give you credit for it. All right. Don't wait until weeks after the assignment's due. Let me know right away. Okay. But then we can get it fixed. Anyway, so say you work this problem on scratch paper or however you do it, and you put your answer in and you check it. It's that simple. All right. Okay. Math for many people does take practice. So even though I got this one right, I can do a similar question right here. Okay. So I guess that's one thing that's pretty nice about this, is I could keep having it generate similar problems as much as I felt like I needed to practice. Okay. Anyway, so if you get it wrong, it will tell you. It might even give you some help or a hint about what to do if you get it wrong, okay? Another thing that you can do is use this Ask My Instructor feature, okay? I would appreciate if you had a question that you use this. The reason is that if you use this Ask My Instructor feature, it sends me an exact copy of this problem along with whatever answer you may have put in. So that way you don't have to explain what the problem was or which assignment, all that. I just get this, I can look at it, and it makes it a lot easier for me to understand whatever you say, okay? All right, now, I did say that you could have unlimited attempts on the homework assignments and the quizzes. So it might go like this. Say you're working something, you're struggling with it, you can't quite figure it out. You keep trying, you keep getting it wrong. Then what do? You can still keep generating a similar question. So it has, this assignment might have the record that I got this problem wrong. But the similar question feature is still an option. All right. Okay, so keep generating a similar question. After every 3 wrong answers, you'll have to generate a similar question to have another attempt. All right. So something else that you can make use of. Let me try and bring something up to put all this together. Hopefully. Let's see. Remember, there are videos. Okay, now you would see if you went through these videos in the order that they're given, then you'll see the problems from the assignments explained and solved in about the same order. Okay, these are sorted by assignment, as I mentioned. Okay, now let's see. Not everybody, I mean, it's like I take no offense to this if this is the case, but I mean, some people they might not want to watch the videos, or that they might not learn it that way, and that's fine. Like I said, doesn't matter to me. You do whatever works for you. Another resource you have is this view an example feature. Okay, so if I do that, it gives me a similar problem, explains some of the steps, shows me what they look like, and then I could just continue through it until I see what I need to see. Okay, this might be enough for you, and if that's enough for you, then like I said, it works for me. Sometimes people say that doesn't quite give enough detail, and if that's the case, the videos might be the better option for you. You can also use this feature, help me solve this, okay? Where what will happen then is it will expect a little bit of interaction. from you. Okay, so like here, I'm supposed to put this in. It's going to take me this far, but then I have to say, well, what is 32 to the power 2 over 5? And if I do that part, then it takes me to the next thing and so on. Okay. Anyway, so that's yet another feature. Also, you can do this. So when you buy access into MyMathLab, you get access to the problems and the help features and all that, but also access to the ebook, the electronic textbook. So if I do this, it will take me to the part of the textbook that's relevant to this particular type of problem. And then you can look at what the textbook says. All right, so think about it. Here's what you've got at your disposal. You've got the videos, and I've got virtually everything in the assignments on the videos. Okay. You've got the help features. View an example, help me solve this. Okay, they'll walk you through the problem. Then you can try to work it on your own. And then you've got the textbook. You've got the ask my instructor, send me a copy, so on. And that's all that you'll have to go through the assignments. Okay. I also can do, just like I'm having this meeting, I can do tutoring online just like this. You know, it will be individual, just between me and you if you need tutoring. Okay. All right. So let's see. That's how MyMathLab works. There's nothing. I mean, look, there's all these other buttons and all kinds of other things. I think everything you need is going to be under assignments and gradebook if you want to. All right. So if you go to gradebook, you'll see the results for the problems that you've done so far. Through gradebook, you can, so I've already, like, to show you, I've worked assignment 1 a little bit. If I click this to review it, it'll let me see what I got right and see what I got wrong. And if it's not past the due date, it will let me continue working it. If it is past the due date and I do review, then I can practice similar problems. It won't change your score if it's after the due date, but it allows you to get some extra practice if you need it. Okay. If you miss an assignment, you can review it also through going to the gradebook. All right. Okay. Now, so that's what I have to say in order to get us started. Let me see. I'm going to stop sharing for a minute. So I said that if you have a question about something you saw, then you can ask me at any time. Just turn your microphone on or put it in the chat. But I'm going to go ahead and pause just to make sure. Is there anything you want to ask about what you've seen so far? All right. Everything's good. All you've got to do is look at that course information document. Okay. Now, the other thing that I want to do in these meetings is go over some of the stuff in the assignments that are coming up. All right. Not all of it. Remember, because it's not the scope of these meetings to go over everything that you're going to see in all the assignments. I'll just go over maybe some things that I expect to cause the most difficulty, the things that people tend to ask me about most often, that sort of thing. The rest of it, you can look at the videos and you can look at in the assignments with possibly the help features. Okay. Anyway, so let's do this. I'm going to share the screen again. All right. And what you should see now is my Word document of stuff that I wanted to go over as part of this assignments that are coming up. So if somebody can, let me know in the chat if you can see that. So I'm not always crazy about Teams, so I always like to hear things are working out. So in the chat, can you see the Word document should say equations and solutions with an example problem? All right. So good. Let's talk about that. Now, I'm going to go over some things and I'm going to do this in a way that I would do it just like as if I was teaching a class on campus. All right. I'll show you some things that are in the very first assignment, okay, which you can start working at any time. All right. Remember, you can work at your own pace. You can work ahead if you want to. I've got all the assignments posted up to the first test. But when you start working those assignments, you'll see stuff like I'm about to show you. So anyway, let's do this. If I do end up doing some online tutoring with you, then this is about what it'll look like. Okay. I've got like a whiteboard I can work with. I've got a writing tablet, and it's just like really, I mean, since I can talk and you can see me and you can see what I write down as I explain it, it's just like as if we were on campus and I was helping you out. Okay. Anyway, so let's do this. Let's start with we're going to solve equations. We're going to learn to solve equations in this first assignment. And let's talk about, before we get to the solving part, what we're dealing with when we're working equations, okay? So like, here's an equation that looks something like one of the first ones that you'll see in the first assignment, all right? And we're going to solve them. And so I thought that it might make sense to recognize if something is even a solution, because sometimes if we can't figure out how to solve something, we can make educated guesses at the answer and see if we can find the answer that way. Okay. All right. So I've got this equation, and I'm asking you, can you tell if 7's a solution or not? Can you tell if -9's a solution or not? And so on. So, well, what would it mean? An equation is just a statement, and you don't do math with letters. Letters are for spelling. So when you see this X in there, it's just a placeholder. We're just asking what's that number supposed to be. I actually like to write things better this way. I think the X's are what's confusing, at least to some people, about algebra. So I almost like it better if I write the equation like this and I don't put a letter in there. I don't put the X. I just put this empty space. It says the square root of 63 minus 2 times what number is equal to that very same number. And like I said, you can solve that equation, figure out what that number is, and that's something we'll learn how to do. You can make educated guesses about it. Sometimes we don't know how to solve an equation. That's what we have to do. But I guess what I'm trying to say is if 7 is possibly an answer and I want to figure out if it is, then that's the number that goes in there. So you can think of the X as just being this number in question, this empty space in that equation that we're going to put a number and we're going to see if it works out or not. Okay. All right. So let's proceed from there. I put that question mark above the equal sign just to be dramatic about I'm trying to figure out if this is a true statement or not. And I get it, and it says 63 minus 14 over here, and there it just says 7, okay? And still I'm trying to figure out if that's true or false. And this says 49 because 63 minus 14 is in fact 49. And I get here, and so this final statement says the square root of 49 is equal to 7, all right? And that is in fact true, okay? So 7 is a solution. A solution is just some number that would make the equation true. All right. Now, so you might think, well, so we found the answer, right? I threw that number 7 out there. I just wanted to see for this first problem if you could tell if it would work, if you know what it means to decide if this number is a solution, okay? And this is how, all right? But it doesn't mean there aren't other solutions, right? Some equations have more than one answer. Some equations have no answer. Some equations actually have an unlimited number of answers. And so it might be hard to know what you're dealing with. So let's try this. Here's second question, is -9 a solution? Sometimes equations, like I said, they might have more than one answer, but you determine whether something's an answer by putting that number in and seeing if it works or not, okay? So here's negative 9, right? Put it in the same way I put that other one in. All right, so let's see. I put the question mark there because I'm trying to be dramatic about it. So does this work or not? So I get here, I get 63 plus 18. I got negative 2 times negative 9 in there. That makes positive 18. 63 plus 18. And so that turns out to be 81. And it says the square root of 81 is equal to negative 9. All right. So I think you'll need some kind of basic calculator for our class. Okay. And I'll show you what I have. You don't need much. I actually don't have a fancy calculator. Okay. So I quit sharing. I take it you can see me again. This is the type of calculator I have. It's not fancy. It's probably $10, $15. Almost everybody who's in the class already has some kind of calculator, but at the bare minimum, I think you'll need something like this. Okay. If I get this calculator out and I say, what is the square root of 81? Figure that out. It is not negative 9. Okay. I'm going to take you back to where we were. Here's that document. Here's what I was working on. I put this number negative 9 in. I worked it out. And then I get here and I'm trying to wonder, is that true or not? Is the square root of 81 equal to negative 9? It's not true. Square roots are positive numbers. If you get your calculator and you type root and then a number, it will tell you a positive number. If you do root 81, it will tell you 9. It won't tell you negative 9. Okay? All right, so let's make a statement about that. So that doesn't work. And so I would say negative 9 is not a solution. Okay, but that's how we tell. So what I wanted to do here is say, before we learn to solve an equation, can we tell what a solution is? Like, would we even know if we found a solution? Okay. All right. So let's go here. Now, I'll remind you, as I go through this, if you have a question at any point, you can just turn your microphone on and let me know what it is. So let's do this. Here's my first example where we'll work it all the way through. Okay. This, or a problem a lot like this, is what you'll see when you start the assignment. Okay. Okay, let me see. I'm going to compare something real quick. So different equations are solved in different ways, and you'll just have to learn the technique for each one. If you practice the assignments, then you can learn that the way you solve this one is different than the way you solve this one. Okay? But from seeing them, from practicing, you learn how you solve them. Okay, now here's the way we solve this one. It has a square root in it, all right? The way that we go about it in order to get this to a point where we can figure out what to do, we have to eliminate this square root as it is right there. It's in the way of us solving it. So we square both sides. All right, so I got this equation. This is where I'm starting, okay? And I'm going to take the left-hand side and square it, and the right-hand side, I'll square it. The reason we do that is because, one, it cancels the square root, and two, what we do to one side, we have to do to the other side. Equations have an equal sign in them. And you could think of that as representing a balance in the equation. Think of it like a balanced scale. If you have a scale that has the same weight on each side and it's balanced, if you take weight away from one side, you have to take away that same amount of weight on the other side. So what you do to one side, you have to do the other to maintain the balance. All right. So yeah, I square both sides. Now, I don't know, is it easy for you to accept that squaring cancels a square root? Let's try it out. So like if I had like the square root of 5 and I squared it, would the square cancel the root? Well, okay, let's go through it. What does it mean to square something? It means you multiply it by itself. Okay. And do you know how to multiply roots together? The way you multiply roots, so I have root A times root B. The way you multiply roots is you multiply the numbers in the root under one common root. That's how you do it. And I tell you that now because it is something that will come up in the future. All right, so square root of 5 times square root of 5 is square root of 5 times 5. And what's that? Well, 5 times 5 is 25. Okay, and what's that? What's square root of 25? Square root of 25 is just 5. All right, now so that gives you a way to understand it, if you like, you know. But what happened? The square does in fact cancel the root, and then we get 5. All right, now so it's good to know that so that we don't have to work it out like this every time just to be sure. But still, I think for the first time, I like to tell you. Anyway, so let's go back over here, and won't I just get 18 minus 7x on the left? Isn't that true? Oh, and that's what I did say over here. Squaring cancels a root. And what do I get on the other side? I get x squared. X to the second power is in fact just x to the second power. Okay, now I've got the root gone. And I wanted it gone because, like I told you, it's in the way of us figuring out what the ultimate solution is. Next thing I do is this. Anytime we see a square in an equation, then we normally solve it by factoring. And in order to solve something by factoring, we need to get 0 on one side, and we need to factor the other side. Okay? Now, one thing that I've done in my classes is I've tried to include a lot of reviewing in the videos. This is one of those things that I'd be happy to review now, and that there's a little bit of reviewing for in the videos. But, you know, you'll have to tell me if that's something you need. The way I'll get 0 on one side is I'll subtract 18 to cancel the 18, because 18 take away 18 is nothing, and it would be gone. And I'll add the 7x to cancel the minus 7x, because minus 7x plus 7x is also nothing. All right, that's what I wanted to happen. I wanted to get 0 on one side and factor the other side. That is just the method that we use. Okay. So here goes. Now I'm here. Now, okay, what I just told you was I need to factor this. That's how we solve it from this point. What's factoring? Well, let's think of it like this. How about on my paper, I'll do a little bit of reviewing over here. So I reviewed about square roots and how you multiply them, and now factoring. So like, let's think of it this way. So 24 is 4 times 6. Now this equation, you hopefully agree with me, is true, right? Is a two-way street. Going this way is factoring, and going this way is called multiplying. Two-way street. If you start with 24 and you say 24 is 4 times 6, then you factored it. If you start with 4 times 6 and you say 4 times 6 is 24, then you multiplied it, you see? So I guess like here, I'm trying to think of the thing or the stuff that you would multiply that would get you x squared plus 7x minus 18. I'm trying to figure that out, okay? All right, now, in order to do that, you need to know a little bit about multiplying, and you need to know a little bit about FOIL multiplication and that, but let's do this. Let's do this. The thing that you multiply together to get x squared plus 7x minus 18, looks like this. It's x plus some number times x plus or minus some other number. And the goal will be to figure out what those numbers are, which you can do by trial and error if you want to, or what you can do it any way you want. But that's the objective, to figure that out. Okay? Now, the way I would do it is this. Figure out, think of two numbers that multiply to negative 18 and simultaneously add up to positive 7. If you can think of what those two numbers are, those are the numbers that we want down here. Okay? All right. Let me pause for a second. Yeah, all right. So somebody, I thought, got a notification for the chat. 9 and negative 2. It's like that's what somebody put in. And I would agree with that. So let's do this. Plus 9 minus 2, right? And not the other way around. 9 times negative 2 is negative 18. And 9 plus negative 2 is positive 7. So it wouldn't work if it was minus 9 and if it was positive 2, because that would multiply to negative 18, but it wouldn't add to positive 7. All right. So here's what we do after that. There's this thing about 0 that we really like, okay? Think about it like this. Suppose that I multiply two things and I get 0, which is what this says. It says x plus 9 is one thing, times x minus 2 is another thing, gives me 0. Okay? So if I multiply two things and get 0, what do you know? Well, you know that one of those things has to be 0. Those are the possibilities. The only way to multiply stuff together and get 0 is to multiply by 0. So one of those things has got to be 0. So it's like either this first thing is 0, that's one possibility, or this next thing is 0. That's just the way multiplication works when you have 0. So back here, when I said I wanted to get 0, it was for this reason. I was anticipating getting to this point, all right? So I got x plus 9 is equal to 0. And then another possibility, x minus 2 is equal to 0. I solve these individually, and I'll get negative 9 for that one, and I'll get positive 2 for this one. So it looks like I found the answers then, right? And perhaps if I was in my math lab, I would type those answers in. And I remember that it said when you put in more than one answer, you put a comma, and so I put a comma in it. I'd say negative 9, comma 2. But there's another wrinkle to this, okay? You get a little more space. Remember, let's see. Remember when we were doing this one? The 7 worked, okay? And the negative 9 almost worked. You know, because like one of them worked and the other didn't. Because the square root of 81 is 9. It's not negative 9, okay? So something like that is going on with this. It's not the case that both of these will work every time, right? And it's not because we did something wrong. It's just the nature of this kind of problem that you get these false solutions occasionally show up, okay? So the nature of this problem is that you have to check those answers to see if they both work, to be sure that they both work. So that's why I started you off with this, because we're going to have to know what it means for an answer to be an answer. Oh, all right. So let's say checking is something you can do just to be sure. But here, checking is a must, like we have to. I can't guarantee that both of those work. Even though I didn't make any mistakes, it just might be the case that they don't both work. There might be neither of them work, okay? So let's start with the negative 9. Okay, I'm going to plug that in, and I'll get 18 minus 7 times negative 9. And then I'll get negative 9 over here, and I'll put the question mark. Now, well, this looks so very familiar to that first problem I showed you. I mean, I know that without going any further, without even knowing what that number in there is going to be, I know that that's not going to be an answer. Because remember, I said that the nature of square roots is that they're always positive numbers. So, I mean, it doesn't matter what that number turns out to be, the square root of it's not going to be -9 because that's just not how square roots work. Okay. But I mean, we took it this far. Let's go all the way with it. So I get 81 again in there, and then I get -9 over here, and that's not right. Okay. It's not a true statement. I plug that number in to this original problem, I don't get a true statement. If it was a solution, I would get a true statement. So how about this? I was gonna make this my final official answer. Okay. Well, I've got to cross out the -9 because, matter of fact, it doesn't work. And it might be that the 2 doesn't either. Okay, so let's go ahead and check it. Remember, the checking is a must. The extra answers, the false answers, show up by no fault of your own. It's just the nature of this problem. So anyway, I'll try 2. I'll put in 18 minus 7 times 2, okay, and 2, right? That's what it looks like if I take this original equation and I put 2 in. And I'll put that question mark again just to emphasize that I'm wondering if this is true or not. So this says 18 minus 14, and that happens to be 4. And my statement says the square root of 4 is 2, and that is in fact a true statement. So, all right, here's my final answer. I'll emphasize it. All right, I originally said -9 and 2. Through checking, I learned that the -9 didn't happen to work, so it's just 2. In the box, you only see 2. In my math lab, if I was working this on my math lab, I would just put 2. Right? If I put -9 also, it'll tell me I got it wrong. All right, and it would let me try again, right? Okay, now, so hopefully, I mean, I guess like whenever I do this, my objective is to go through it really slow because I don't know where everybody is. You might have had trouble with the roots, you might have had trouble with the factoring. Maybe you've never seen anything like this part, who knows? All right, so I tried to go through it nice and slow. Obviously, you don't have to work it as slow as I did. If I was working this on my own and I wasn't trying to show everybody, I think I would jump straight to this step and then the answer, okay? But whatever you have to do, you work at your own pace. I just wanted to make sure and show you everything that you need to see, okay? Anyway, all right. So I didn't hear anybody turn their mic on and ask a question. I didn't see anything in the chat, so I'm going to take it you're doing okay with that. Now, you remember when we were looking at my math lab earlier, I saw a problem a lot like this. Okay, and now I want to learn how to do that one. But before we do this one, I think I should talk a little bit about fractional powers. Okay, so you know, powers, exponents. I don't know. You ever seen anything like this? 2 to the 3rd power. So if you're in college algebra, you've probably seen something like that before. What's an exponent? It means you multiply repeatedly, you know? So 2 to the 3rd power is 2 times 2 times 2. And that turns out to be 8 if you work it all out. Now, I know we have calculators, and I'm not trying to say that you can't use it to do this, but I think it's always better to know more than to know less, okay? So if that's how you work out a whole number power, how do you think you'd work out a fractional power? Well, you could use a calculator. I mean, some of the time at least, but like I said, it's always good to know. So they can't be the same way because I can multiply 2 by itself 3 times, right? But how do I multiply 125 by itself 2/3 of a time? It just doesn't make any sense. So the way that we do is like this. I'll give you a rule, and this will be a rule that you use all throughout math. However far you're going to go, this is how you'll understand a fractional exponent, all right? So if I have some number a to this fractional power m over n, then you can think of it this way, that n number is going to be the root that you apply, and that m number on top is going to be the power, okay? So in other words, here's how I understand this number a to the power m over n. It's the n root of that number a, then raised to the m power, okay? So you apply a power and a root to this number. You could do it this way. Take the n root of the number a, figure out what that is, then raise it to the power m. Or you could actually do it the other way. It doesn't, the order doesn't actually matter. You can take the number a, raise it to the power m, and then take the n root of whatever that number is. Doesn't matter the order you do it, just know that that bottom number is the root, the top number is the power. Okay, so well, let's try to do this one that way. So 125 to the 2/3 power. So based on what I told you over here, that's going to be the third root of 125, then to the second power. By third root of 125, I'm looking for a number that I multiply by itself 3 times to get 125. And you can go down the list. It's not 2 because 2 to the third power is 8. It's not 3 because 3 to the third power turns out to be 27. So I could just keep going, and it turns out it's 5. All right. Okay. 5 to the third power is 125. So the third root of 125 is 5. And then what do? I take that and I square it and I get 25. Okay. So there, now you know how to do it. Okay. In case you had to ever dissect a fractional power, I've just showed you how it works. If you use your calculator, then, obviously you can try to use your calculator too, but, when you're doing algebra, a calculator is not always an option because a calculator is for numbers, okay? Let me see, I just got a thing that somebody was in the lobby, but it went away. I don't know what happened. All right, so let's try one more. So 25 to the 3/2 power. This would be the square root of 25. Okay, and to the third power, right? That's how it's supposed to work. This bottom number is the root, the top number is the power. So square root of 25. Let's do that first. Square root of 25 is 5. So then I get 5 to the third power, and then 5 times 5 times 5 is 125. Okay, so now you know. In case you ever had to rearrange these numbers and know that the bottom one was the root and the top one's the power, then, all right, that's the whole story behind it. Okay, now let's use a little bit of what we just learned to do this one. All right, now, every equation has its own method. And part of the way I encourage you to go through this class is to learn how things look, So like this equation we did here, it has a square root in it. Then the approach we took was to square both sides. And the reason we did that was to eliminate the root because it was in the way. So if you saw another one that resembled this, you'd probably do it the same way, right? Now, this one here, it says x to the power 5/2 is equal to 32. It looks nothing like that, okay? And so obviously it's going to have a different method. You're not going to work it the same way. But I'll do like this. Let me do, I like analogies when I teach math because, often if you learn something new, there's a good chance you've seen something similar before. So it's kind of like this. If I said x minus 32 is equal to 1, then there's something I do with the number 32 to get the x by itself. Because when we solve an equation, the general procedure, I'm not going to say every equation everywhere in the world all the time works just like this, but the general procedure is to start with whatever the equation is and get to something like this. Get the x by itself, reduce it to the point where it says x equals, and whatever's on the other side will be the answer. That's generally how you do it. The way you get the x by itself varies from problem to problem. Now with this one, if I'm trying to get the x by itself, I've got to move the number 32. And the way that I do that is I add 32 to both sides. So there's a way that you deal with every number or thing that's in the equation. In this case, what I do with that power, the way that I move it to the other side is actually pretty simple. I invert it, I take the reciprocal. In other words, a power of 5/2 on one side of the equation is going to be a power of 2/5 on the other side. That's the method. That's the way it works. Now, there's more details about why it works that way, but it's simple enough just to say it like that. It's kind of like over here. Negative 32 on one side of the equation is positive 32 on the other side. Okay? If I had an equation like this, 5x is equal to 15. Multiplying by 5 on one side of the equation is dividing by 5 on the other side. Okay, there's always something like that. Okay, so yeah, if I've got 5/2 here and I want to move it to the other side, it's going to be 2/5 on the other side. Okay, now you can do this with a calculator if you want to. All right, it's easy enough to push buttons. Sometimes though, if you don't know how to use your calculator the right way, let me tell you this, many of the questions I get when people are getting the wrong answer on my math lab and they use Ask My Instructor or send me an email, a fair amount of the time, it's because they're not using their calculator the right way. So, okay, I mean, do we have something to fall back on? Yeah, you can use your calculator, but what if that's not working, or if it's giving you an answer that just doesn't seem realistic? I showed you another way to do it, all right? So isn't it like this? Didn't we say that for a fractional power, the bottom number is the root, the top number is the power? So this would be the 5th root of 32/2, okay? And you could do these individually on a calculator. You could take the 5th root on a calculator and then square it. You can figure that number out by yourself. What's the 5th root of 32 mean? It means what number do I raise to the 5th power to get 32? And that is 2. 2 to the 5th power is 32. 2 times 2 times 2 times 2 times 2 is 32. Okay. And then so I'll get like this. Okay, 2 squared is 4. And then I'm done. Okay. Now, all right. The checking on this one. Well, what did I say about the other one? Let's see. For this one, I said you must check. And I double underlined it. It's like the checking's not optional. False solutions show up sometimes to this type of problem. That's just the way it is. So the checking's not optional. Now this one, you can check it if you want to. I mean, if it makes you feel better. You know, like what if it's the test or something and you don't get a second chance at an answer? For every assignment, you can repeat them as much as you want. The tests are the only exception for that. So I guess if you're taking the test, you could check it and made you feel better, then put it in, but it's optional on this one. You don't have to. If you did everything right along the way, this answer is guaranteed to be correct. Okay? Now, I wanted to take one that was like this one that was also on the assignment. So notice with this one, it looks something like this one in that it has a fractional power. So it probably has a lot in common with the one we just did as far as how you work it. Okay, so you might look at it like this. When I solve this equation, I'm going to end up here, right? That's how it works. you go through the steps, whatever they are, and then your last step is x equals answer, and that number is your answer. Okay, you get the x by itself. So I got to figure out, well, what do I do with the 3/2? Because I got to move that somehow. I got to get rid of that. And then what do I do with the 2? Because I got to move that too. But I think we've seen how you move each of those numbers at this point. All right. Okay, and we're going to work from the outside in. Okay, so first, I'm going to move the 3/2. I'm going to do that first. And then I'm going to move that 2 second. Okay, so how do you move the 3/2? Well, we did say that 3/2 on one side would be 2/3 on the other side. Okay, all right. What did we say? We said a fractional power, if you would like to move it to the other side, would just be inverted. Okay. And then I need to know, what's this number? What's 64 to the 2/3 power? Is a calculator an option? Yeah, you could. I mean, it would depend on your calculator, and if you're having trouble getting your calculator to work and give you what you know to be the right answer, then let me know. I can help you with your calculator. But you might try that. 64 to the 2/3 power. On my calculator, the way it looks is I press 64, I press this key, that's allows me to raise a number to a power, and then I do parentheses 2 divided by 3. Okay, so that's my calculator. My calculator is not real advanced. It's not a graphing calculator. Your calculator may very well be different than mine, but that's how I would do it on mine. You might try it. But you know, I showed you this, so I think it's good to know. I mean, I want you to know how to do stuff. I want you to know as much as possible. So can't we do it like this too? Let's try to do it. 64 to the 2/3 power is the third root of 64, which is then squared. I would need to find the number that I raised to the third power to get 64. That is 4. It's a matter of fact that 4 times 4 times 4 is 64. And then I would square it and I would get 16. Okay, 16. So this number is 16. Now, what do I do with the 2? Well, that one's easy. I just add 2 to both sides. So I'll get 18. All right, there we go, 18. Add 2 to the left, I get the x by itself. Add 2 to the right, I get 16 and 2, and I get 18. All right, so again, the checking's optional. You can check it if it makes you feel better. Go for it. But 18 is guaranteed to work if you did everything right, and I did everything right. Okay, so those are some of the equations that are in the first assignment. Let's look at the next thing is functions, okay? So I want to start with, let's do like this. The first problems on the assignment that deal with function notation look more like this one, but I don't want to start there because, like I said, I'm going through these real slow, okay? Making sure that you have a chance to see everything that you might need to see, because I don't know where everybody's at, and I don't want to go over stuff too fast. So I want to start here with like the basic idea of a function. So a function, you can think of it as like a box that has a place for an input, and then the function does whatever it does and spits out an output on the other side. So input goes in, output comes out. Number goes in, number comes back out. Okay? Normally, but not all the time, X is the number you plug in, and Y is the number you get back out. But functions are just inputs and outputs. I think that so many things about algebra become a lot simpler if you just think of a function like that, okay? Anyway, now here's my equation that is working like a function, okay? A function is not necessarily an equation, but it's anything that converts an input to an output. So we will see things that are functions that are not equations. All right, it will happen. So that's why I want you to think of it like that. Now, there's something called function notation. And the way it works is it looks like this. And we read it this way. So that right there, the f parentheses x close parentheses, we read that f of x. And that's called function notation. And we write that instead of y. The reason we do that is because it simplifies this whole box type of thinking. Okay? Here's how it does that. If I say my function is f of x equals x squared plus 1, then I can summarize the inputs and outputs with this right here. It summarizes the whole thing. If I write f of 4 is equal to 17, it says for that function, if the input is 4, the output's 17. So of course, like you can draw the box to say that. You can say 4 goes in, 17 comes out. You can use the function notation to say that. And there's even a third way. Have you ever seen something like this? 4 comma 17. This is called an ordered pair. Okay. And what does it say? You know how in ordered pairs, the letters are alphabetical? It says that first letter, that first variable was X, and the second one is Y. So that's a third way that is done. And wouldn't it be nice if everything was always done the same way and it was just one way? Well, unfortunately, that's not true. Okay. Sometimes we use function notation. Sometimes you'll see ordered pairs. That's just the way it is. But if you can right now see how they're just different ways of saying the same thing, then I think it'll be fine. Okay, so that's what function notation is. Now I want to, I'm going to skip this one for now. We'll come back to it, and I want to do this. So something that's connected to this and something that is related to doing math and science and engineering in general is reading information from graphs. Okay, so people like graphs. People like graphs because it's an easy way to summarize information. Okay, so if somebody gives us a graph, we're going to have to know how to read the information that's there. Okay, so I would like if you could take what I just told you and answer these two questions. So the first one says f of 4 is equal to what? And the second one says f of what is equal to -1. Okay, all right, so let's take those one at a time. So how did we understand this just a minute ago? It says for the function, oh, wait a second. Remember how I told you that not all functions are going to be equations. A function is just something that gives you an input converted into an output, or an x paired with a y, okay? It's not necessarily an equation. So here, there's no equation. This graph says y is equal to f of x. It doesn't tell me what the equation is. The equation might not even exist. It might just be a bunch of paired data, okay? So yeah, I don't have an equation. There's no way I could possibly do this with an equation because there isn't one, all right? It just says x is left and right, y is up and down, right? The first number in the pair is x, the second number is y, all right? But yeah, okay, this first question says, if according to the information on the graph, if x is 4, what is y supposed to be? Well, that would be reference to this point right there, wouldn't it? If x is 4, y is what? Well, this point right here says that x is 4 and y is 1. I didn't put marks on it. I didn't have graph paper, but whether we count the little marks or whether we look at the ordered pair for the point, that's the information that we have, right? So, okay, that answers the first one. F of 4 is equal to what? I'll put my answer over here. F of 4 is equal to 1, according to that picture, according to the information I see on the graph. What about the second one? So that second problem, It says f of x is equal to -1. I think another way to write that might be f of what is equal to -1. Do you remember earlier when I said that I think that some of the time, what makes algebra complicated is all the variables, all the letters, the x's and y's and so on. And so at least when I teach, I sometimes try and find ways around that. So this question right here, which you'll see in a form a lot like this on MyMathLab, says, what is the x, obviously, when the y is -1? Okay, and you can look at the graph and you can figure out what the x is supposed to be when the y is -1. Doesn't that refer to this point? Okay, yeah, it does. And we can get our answer from the information included on that point. If you like to write it with a question mark, f of what number is equal to -1? Yeah, well, so this is the x, I'm looking for it, and I'm given the y, it's -1. All right. Nonetheless, though, either way, my answer is right there. According to the information on the graph, f of -7 is equal to -1. I was given the y, and I'm supposed to find the x that's matched with it or paired with it from the information on the graph. Okay. So, all right, that's a combination of two topics: knowing how to read function notation, knowing how to identify what's x and what's y in the notation. So much of math is just learning to read all the symbols, I promise you. It's not always as hard as it looks. You see a lot of complicated symbols that make it look difficult, but once you know what the symbols mean, it's not always so bad. Okay, so I had to know to read the symbols, but also know how to read the information on the graph. All right, now we also need to do some calculations, right? So sometimes, yes, I will have an equation for the function. This one, the equation's given. It says the function f of x is equal to x squared plus 1, okay? All right, so I'm given the equation, given the formula for it. Now, that would make this one relatively straightforward to answer, wouldn't it? Okay, I mean, what are you supposed to do? You're supposed to plug that in for x. I'm going to get -5. I'm going to square it. I'm going to add 1, and that's going to be 26, right? Because -5 squared is -5 times itself, which is going to be positive 25 plus 1. So no big deal on that one. But what about this one? So remember when I said that I think sometimes what makes math complicated is all the letters, the x's and y's and z's and so on. So my experience with the class is that this x really confuses people with this one. You might know that you're supposed to plug that in. That's the input. Just like you're supposed to plug in the -5. But the fact that there's an x there and an x there confuses a lot of people, okay? But how about we'll think of it like this. I promise you, it's just like plugging in the -5. It's just like it. It's no different at all. Even though the x there looks like the one that's up there, it's not any different than plugging in the -5. So I want you to think of it like this. Maybe sometimes it would be easier to imagine this function like instead of writing x, I just wrote an empty spot, and that's where the input goes. You know, whatever the input is. If the input is -5, you plug the -5 right there and you do the math. If the input is this thing, because algebra is doing math with unknowns, with letters, with variables, if the thing you're plugging in is a variable or a letter or an unknown, like x minus 2, you put it in the same way. It wouldn't be any different, okay? So how about this? Like that, if you like that, that's great, you know, but you can imagine this way. You know, if it helps you think about it, then think about it like that. Now, what would it look like then if I took this and plugged it in right there in that empty spot where the inputs are supposed to go? it would look like this, x minus 2 squared plus 1. Okay. And what would I do from here? Well, it would be just like this one. You just got to work it out. You got to square this, and if you can add stuff together, you do that. Okay? All right, so let's see. Do you know how to square x minus 2? Let's do a little reviewing over here. Here's what I see a lot. X minus 2 squared. Here's the way some people think about it. They think, well, we should square each number in there. X squared, okay, x squared, and negative 2 squared, 4, maybe? Well, a lot of people do that. It's not right, though, okay? But I guess it's just really tempting because a lot of people do that, all right? So yes, that's tempting, and I don't know what about it is alluring, and people do that, but that's not the way you do it. So let's look at it like this. Do you remember when, I know we saw this recently. Where was it? Where was it? Yeah, well, with exponents, 4 squared, what's that mean? It means 4 times 4. Whenever you square something, you're just multiplying it by itself. I mean, no matter what it is. So x minus 2 squared is x minus 2 times x minus 2, because that's what squaring is, multiply by itself. Well, how do you do that? Well, the way we multiply things like this is with FOIL multiplication. So I get x times x times minus 2, minus 2 times x, and minus 2 times minus 2. So I get like so. If I can add any of that stuff together, then I do. So I get x squared minus 4x plus 4. Okay. So that's what I needed to know how to do. And I wanted to tell you, whatever your instinct is, don't do it like that. Okay. All right. So anyway, I squared that out. I get x squared minus 4x plus 4. That's this part. And then I get plus 1. Okay. And my next part that I would do is if any of those terms are compatible, if I can add them together, then I'll do that. And I only see that 2 of them can be added, like the 4 and the 1. Nothing else can be added. All right. So x squared minus 4x plus 5. That's as far as we can take it. If there was anything else there that could be combined or canceled or whatever it was, then we would do that, all right? But what I wanted to point out more than anything else about this is that even though this looks way different than that, isn't it true that the way you approach it is exactly the same, okay? Even if it doesn't seem like that naturally for you, the way you approach it is exactly the same. Okay. All right. Now I have another one or two on here, but what I wanted to do, I wanted to give you a chance to try some of the things that you saw me do. Okay, so here's what I'd like to do. Oops. I'm going to open up my MATLAB again. And I'm just curious to give you a shot and to see if you can get some of these right. Right, because this is the thing that you're going to have to work on by yourself. All right. So here's this one. Okay. So what I want to do is throw that one out there, and first person who gets it, who can propose an answer, either turn your mic on or put it in the chat, and then we'll try it out. And we might go over it. If you have a question, we might address the question and so on. But here it is, and I'll give you a few minutes to work on it, or however much time it takes. But as soon as you get it, let me know, and we'll see if you're right about it. Looks like somebody's got it. Let's see. 5. Let's try it out. Let's try it out. Okay, so this is how you do it. 5, right? Check the answer. Yes, because you're going to get 25 in there, and it says square root of 25 is 5. So let's see who is, you mind telling me, so when you solve it, like the one that we did, you get 2 answers, and then you check them both. And if you got one answer, that means one of them got eliminated. Can you tell me what that other one was that you eliminated? -7. Yeah. Okay. All right. That looks good. Okay. Now, some of you were trying to work that possibly. And if you got stuck somewhere, if you didn't get negative, or if you didn't get 5, do you have anything to ask about it before I go on? Because we said that you could turn your mic on anytime, ask a question, but I just want to give you a chance if you got stuck somewhere. Or if once you tried it, it wasn't easy as you thought it would be, you could ask. Okay, so let's try a few more. I want to try one that was like, let's see. That one though. I'm looking for some different numbers. I don't know if it's going to give me any. Yeah, I can't remember which one we did. Let me. Okay, well, this one shouldn't be too bad. Let's try this one. Same way. Try it on your own. First person to get it, let me know in the chat or turn your microphone on. All right, so 9, let's check it out. This is how we would do it. We answer it, we put the answer in, we check it, and it is correct. All right, so great job on that one. Well, so those are the 2 main types of equations that we already talked about. Now I wanted to show you one that was like, let me see. So I told you, like, we're not going to be able to do everything in these sessions, but I did one like this with function notation. Right, you plug in the number. In the case of a number, you plug in the variable expression. In the case of that, x plus 5. So we talked about that. And I wanted to show you. Now, I would ask you to do this one because it's kind of like that problem with the graph that I did, but I'm not sure you'll be able to see this well enough on Teams, okay? But that I did one like this. Even if you're working it on your own, you could zoom in. You might be able to see it well enough, but I don't want to take any chances. So I want to show you one last thing that you'll see in this assignment, and it's like this, okay? All right. Now, this one is sort of like this one, but it has more stuff in it. It's more complicated, okay? Oh, this is my cat Melvin. I wanted to put him in here because he is on, maybe you recognize him from this. Yeah, he's the cat that I put on all the tiles on Canvas. So I wanted to tell you who he was. Every time I'll probably tell you about a different cat, but Melvin's a good cat. Anyway, so here's this equation. Let's learn how to do this one. Now, let me see. I got to find my pen here. All right. Like the one I showed you earlier, because this has roots in it, we'll probably square both sides because that will help eliminate the roots. But there's two of them. And if you square both sides the way this is, you'll have to use FOIL multiplication and it won't eliminate the root. Okay, so there's not really an easy way to eliminate the roots in this one in just one step. Okay, so let me show you how I would do it. Now I'm going to show you how I would do it. And if you see one that's like this, you can try to do it the same way, right? So you learn by imitating is what I'm going to try to get you to do. You can always try to figure out your own way. If you're really good at math and you're comfortable with what you see, you can figure out your own way. I don't want to discourage that, okay? So somebody might try this a different way than I do. But the way that I'll show you is like this. I will isolate one of the roots on one side so that if in the next step I square both sides, at least it will be gone, okay? So I'll move this plus root x minus 8 to the other side, and I would do that by subtracting from both sides, okay? Now I've got this one isolated, so I could then square both sides, okay? And it will kind of make a little bit of a mess over here, but we'll just have to deal with it. There's just going to be stuff over here. So if I square this side, what do we say? Well, what was the whole point of taking an equation that has roots in it and squaring both sides? It was because a square cancels a square root. So this is just x because the root and the square cancel. That's why I did that. But what about over here? Well, remember when I said that don't do things like this. If I have x minus 2 squared, for example, that doesn't mean I just square each individual term. To square something always means that you multiply it by itself. Okay, so this deal right here, I've got to multiply it by itself. So I got to take 2 minus root x minus 8. I have to multiply it by itself. 2 minus root x minus 8. Okay, how do I do that? Well, I told you I don't mind reviewing some stuff. So if you need to review something, go ahead and ask about it anytime, but FOIL multiplication is what I would do. First, outside, inside, last. All right, so let's do that. If I multiply the first thing in each parentheses, I get 2 times 2. That's 4. If I multiply the outside terms, I get 2 times negative root x minus 8. So a positive times a negative is a negative. And otherwise, it's 2 times root x minus 8. Inside, I get negative root x minus 8 times 2, which is, again, negative 2 root x minus 8. And then last, let's do like this. I get a negative times a negative. Well, okay, so that it's at least plus. Whoops. Okay, so it's at least plus. But then I get root x minus 8 times root x minus 8. How do you do that? How do you do that? Well, I've tried to have some continuity to our lesson today. Way back up here. Remember? Yeah, when you multiply a square root times itself, it cancels. Right? That's like squaring a square root. And that's what we have down there. All right. So when I have root x minus 8 times itself, that's like squaring it. It cancels it. And I get x minus 8. Okay. Now, if it would help you, if you want to see everything, this is like first, this is the outside, this is the inside, and then that is the left. Okay. Now, like anytime I'm doing algebra or math at all, I want to simplify as I go along. If I can reduce things, if I can cancel, if I can combine things, then I'll do that as I go along. Okay. All right. So of all the stuff here, I'm going to see if I can combine any of it. So I've got a 4 and a -8. Those are numbers. You can add those together. You get -4. I get -2 root x minus 8 and -2 root x minus 8. Now, it might not seem like it, but that's like -2m minus 2m. What's m? It's a variable. It's algebra. Right? It's, that's algebra deals with unknowns, variables, letters. But anytime two things are exactly the same, they could be combined. That's -4m. So this is like that. -2 root x minus 8 and another -2 root x minus 8. So that's going to be -4 root x minus 8. You can always combine things that are exactly the same, no matter what they are. And these are things that are exactly the same, just like this. -2m take away 2m is -4m. All right. And then one more thing, x, can you add that to anything? No, you can't add that to anything. All right, so I get x then. And anything else? Let's see. I can, well, how about this? Remember we said that we should isolate the x. We should try to get it all by itself. Okay. So I'm going to do this. I'm going to subtract x from both sides. At least that's gone. Getting rid of stuff, moving it, isolating it. And I'm going to add 4 to both sides for the same reason. At least that's gone. And look what I get. What do I get over here? I get 4 minus 4 root x minus 8. All right, now I'm getting closer. I'm not all the way there, obviously. But now I'm like, to this point, I'm kind of like where I was with that first problem. Okay? All right. So still, I want to move things. I want to combine them. I want to reduce and simplify. So I'll do this with this last few steps. I see that I've got this -4. So I'll divide both sides by -4. Because again, at least I'm reducing the numbers a little bit. Okay. So if I do that, now I'm down to -1 equals root x minus 8. Okay. And now I am one step. I think I'll have it. I still have this one last root left. Okay. And we said before that we could square both sides to deal with that. Okay. So with this last one, I'll get 1 on the left. I'll get x minus 8 on the right. And if I add 8 to both sides, then I'll get 9. Okay. And so 9 seems to be the answer. Okay. Now, we did say with these equations that have square roots, like the very first one we did way up there, that I have to check them. The nature of the equations that have roots in them are such that even if you do everything right, you might still get a false answer showing up. We'll have to check it, all right? So we get, so let's see, here's my equation. It says square root of x plus square root of x minus 8 is equal to 2. And I solved it. I found out the x was 9. So I'll get square root of 9 plus square root of 9 minus 8 is equal to 2. Okay. All right. 9 being the proposed answer. So this right here, square root of 9, 3 plus square root of 9 minus 8. Well, that's 1. And 2, it says 3 plus 1 is equal to 2. Well, that's obviously not the case. Okay, that's false. So it turns out like the only number I found didn't happen to have an answer. All right, it didn't check out, right? The only thing that could have been an answer was 9. If there is a solution to this problem, I would have found it here. And maybe I would have found some that didn't work also, but if there was an answer, it would have been here. I would have seen it. And the only number I got didn't actually work out when I plugged it in. Okay, so all right, what do we do in that case? Well, let me show you back on MyMathLab. All right. Let me see, we need to go here. Sorry. I think this is like one of the last few problems. So see how, so yeah, this one is kind of like the one I just did. And it says choice A or B, the solution set is, and you can write the numbers there that are the answer and then check your answer, or no solution. Okay, so this one just doesn't have an answer. The only number that could have been an answer didn't happen to work out. So there just isn't one. So there are problems in math that are conceived of, but are actually impossible to solve. So this is one of them. There is no number in existence that could ever make this equation work. Okay, that's what we showed by doing it this way. All right, so there, that one is like 19 and 20. So when you get to the assignment, you get to doing 19 and 20, then they're going to be a lot like this. Okay, so I'll make one more note about it. Assignment number 1, compare with question 19 and 20. And you'll be looking like something a lot like this with different numbers, of course, something a lot like this. Okay. All right, now that is the last one I wanted to show you. I want to give you a chance to ask anything that you might have to ask. All right, I've given you lots of chances to do that. I'll give you one final chance. You saw a lot of stuff, but it wasn't everything that's in the assignments. Also look on Canvas at the videos. All right. Is there anything?
Hello.
Yes.
This is Pilar Tale. I have a question about the test. Can you hear me
Yes.
very well? Are we gonna be able to use calculators during the
Yeah,
test?
you can use a calculator.
It's also it give you some the program too. The math also can
Yeah,
give you.
you can use any calculator you want for everything.
Okay. Okay. Thank you.
Anytime. Now that's like we haven't done that yet, but once you read the course information document, so say we're back on Canvas and we go, oh, whoops. Sorry, back on Canvas. There's Melvin again. So our class is this one. And go here. Now, once you read this course information, there questions like that are addressed about that you can use a calculator for anything, and you can actually use notes on the test too, but it's all explained in here, okay? Now, you wouldn't have had time to read that yet, but go ahead over the next day or so, read that course information document. Sorry, I forgot I wasn't sharing my screen. I was just showing on Canvas that you'll find the course information document. Anything else? Okay, so I have recorded this session. I will be posting it, and I'm going to send out, hold on a second.